Hello, welcome to episode 4 of the Minecraft clone tutorial series. Today we are going to be drawing the first textured quad on our screen. This is going to be the first major step in creating our first block, so let's get into it. So we already did the hard part of getting the render pipeline down for this basic triangle in episode 3. If you haven't seen it, link in the description. But now let's go ahead and change this into a square, because that's what we want for our blocks here. And so for this, we're going to have to go over a couple things. So let's go ahead and first create the actual square itself. So I'm going to change this top vertex, bottom left, bottom right into 4. So I'm going to change this first one to the top left and shift it over 0.5. And then I'm going to copy it and paste it down, and then shift this one over to 0.5 to the right. And then I'm going to just, for easeability, I'm going to take the bottom right and put it above the bottom left. There's no particular reason, but I'm putting this in clockwise motion. So basically it's going top left and then top right and then bottom right and then bottom left, kind of a clockwise motion. It's just easier on your brain to do it that way. So now we have to get into how does OpenGL draw things, because you'll notice that if we go down here to our GL draw arrays and we change this to 4 for 4 vertices now, and we run it, we only get one triangle. It's a different triangle, definitely, but we don't get the fourth vertex. So why is that? The reason is because of the way that we draw things in games. And for this, I'm going to pull up a little example. So you would think that a square would be drawn like this. You would just go one vertex, other one, the down, down, down. You'd also expect it to be a lot straighter than that. But you would expect your square to be drawn like this. But this is not how OpenGL does it. And this is because of efficiency. So OpenGL draws things in triangles. So it would go more like this, at least for our example. This vertex to this vertex to this vertex, back to there, and then we do this vertex, and that completes our square. And the reason we do this is because drawing triangles is a lot easier, a lot more efficient in the graphics card than drawing complex shapes. It's not as bad with drawing like a quad like this, but let's say you have like a giant random model here with a ton of different vertices and depths and all that. It's way easier just to split it into triangles like this than to try to draw it all at once. It doesn't really make a lot of sense. So now that we know that everything is split into triangles like this for efficiency purposes, we can go ahead and figure out how to do this. So the way that we do this is we actually use what's known as indices, and this is just indexing our vertices, which means that go from this one to this one to this one. You just basically specify the order in which OpenGL draws them. So for this, we're going to create a new array. We're going to create an array of type unsigned integer, and that just means that they cannot be negative. And you don't want your indices to ever be negative, so that's good. So uint indices equals, and let's go ahead and specify indices for 2 triangles. So for the top left, or the top triangle, which is the one we saw on screen earlier, I'm going to go ahead and go from the first, and I'm actually going to show you the index. So it's 0, 1, it starts at 0, 2, and 3. This is just easy visual. So we want to go from the top left to the top right to the bottom right, and then that creates our first triangle. Now for the bottom triangle, we need to go from the we need to pick back up where we left off, go from the bottom right to the bottom left, and then back up to the top left to complete our bottom triangle. And that's all we need for our indices. But now we actually have to actually tell OpenGL use these. So for this, we're going to go to our onload here where we have our render pipeline, and between the VAO and the shader program, I'm going to put it here. It's not really like necessary to put it in a specific spot, but as long as it's in the onload method, I recommend that you put it in the same spot as me though, just for easeability. So I'm making a little space here, and I created a variable called EBO here. And now let's go ahead and create this EBO. The EBO is just a shorthand for the indices. It's also called an IBO. I think it's index buffer object, if I remember correctly. So we do ebo equals gl.gen buffer, and this generates our ebo buffer. And now we need to bind this to the current context of OpenGL, because remember we bind things to contexts in order to interact with them. So we're going to do gl.bind buffer, and here I'm going to do the buffer target dot, instead of array buffer, we're doing element array buffer, and we want to bind the ebo we just created. And now we're going to actually put the data onto our buffer. So I'm going to do gl.buffer data, and I'm going to specify the buffer target as the element array buffer we just bound. So buffer target dot element array buffer. And then for the data, we need the size first. And for this, we're going to do just our array size. So indices dot length. And then we're going to multiply this by the size of an unsigned integer. And the reason we're doing unsigned integer instead of float is because we have an array of unsigned integers, and the reason we're multiplying by it is because we want the size of the data in memory, not the amount of elements. So now we need the actual data, so we're going indices, and then we need the buffer usage hint, which is static draw, the same as the one we set for our VBO. And the last step, just for good practice, we're just going to unbind the VBO. Element array buffer 0, unbinding the EBO, all good. And what you'll notice with this process is that it is almost identical to the process of creating a VBO. It's pretty much the same thing, just instead of array buffer, it's element array buffer, and instead of size of float, it's size of uint. So that's pretty cool. It's once you figure this out with the VBO, you should be able to reproduce the EBO pretty easily. So now we need to still use it. So let's go down to our on render frame, which is where our drawing is happening, and below where we bind the VAO, I'm going to bind the EBO. So gl.bind buffer, and then buffer target dot element array buffer, and then we need to specify the one we want to bind. So we're binding our EBO we created. And now instead of doing draw arrays, I'm going to comment this out, and then above it I'm going to do gl.draw elements. And then for this, the first argument is the primitive type I want to draw, and we're drawing through using triangles. And then we want the amount of indices we're going to use, and for this we're just going to get our array indices dot length. And then for the type, we're doing draw elements type dot unsigned integer because we have an array of uints. And then the last argument's deprecated, just put a 0 here. And that should be all good. So with that, we're pretty much done. Just good practice here. In the unload, let's go ahead and delete our EBO. So delete buffer EBO. All right, and that should all be good. We go ahead and run this. Hopefully it doesn't blow up. And we got a square on our screen, so that is pretty cool. So now let's get into the texture loading, and it's a little bit different. So let's go ahead and get into it. So the first thing we have to do is we have to go to NuGet again, or Nugget. I still don't know how to say it, and manage the packages. And now in browse, we are going to look up this particular library. We're going to do stb image sharp. Make sure it's stb image sharp. And mine is already installed, but yours should say install here. Go ahead and click install and run it, and it should be the exact same process as installing OpenTK. Just press OK, and it should say finish down here. And when that's all good, go ahead and go back to your game, and in your usings, we're now going to add using stb image sharp. And this is going to be for processing our images. And so for this process, we're going to go ahead and create a new folder. So I'm going to go over here, and I already had it. I just deleted it here. Add new folder, textures. And we're just putting this in our general directory here. And then we want to go ahead and add a texture. And so I have it in the link in the description. It's just a very basic Minecraft dirt texture. I have it right here. Let me go ahead and just drag and drop it into your textures folder. Make sure it's actually in there. And there you go. All right, so now we need to go ahead and get texture loading working. So for this, we're going to need to do a couple things. First, we're going to go to our instance variables here, and we're going to create one for our texture ID. So I'm going to do int texture ID. And then in our on load, we're going to go ahead and load our texture. I'm just going to do it at the bottom, because why not? So for this, I'm going to make a little comment and say textures. All right, so for this, we're going to do texture ID equals gl.gen texture. And then we need to do a couple things. So we need to set the active texture, and this is using setting whatever the active texture is in the texture unit. And don't worry about this too much. I will get into it later, but a texture unit is basically like like a group of textures grouped together, usually in something no longer larger than 16 textures, and they're indexed from 0 to 15, I believe. And basically it's just for efficiency purposes. But since we're only working with one texture right now, and we're probably only going to be working with a texture atlas for simplicity, this isn't really going to matter too much. But if you would like me to get more into it, let me know. So let's go ahead and activate the texture in the unit. So we're going to do gl.activeTexture, and we're going to put texture unit.texture0 for the first texture in the texture unit. And now we need to go ahead and bind this texture. So we're going to gl.bindTexture, and we're going to set the texture target to a texture 2D because we are just creating a 2D texture. And then we need the ID of the texture that we're binding, which is the one we just created, texture ID. All right, and now we need to set some parameters. So I'm gonna go ahead and make a comment, call this texture parameters. All right, and I already have them here. I'm gonna go ahead and copy and paste it because it's a lot of writing, but I'm going to explain things anyways. So here are the 4 parameters we're going to be using. To create, to specify a parameter, you do gl.textParameter, and you want to target the currently bound texture 2D. So you put texture target.texture 2D. And then you need to specify the parameter you want to adjust. For here, we're adjusting how we are wrapping our texture, which means that if we exceed the size of our texture in our texture coordinates, we will be wrapping it instead of like stretching it, for example. So for this, we're going to specify how we're going to be handling the texture wrap. And for this, we're going to be doing repeat. And the S and the T, I believe it's horizontal and vertical. I'm not too sure. I've never actually only used one of them and not the other. So for Minecraft, you would use these settings. The next one is the mipmap, the min and the mag filter for your mipmap. Your mipmap is basically like whenever you are closer or further away from an object, the texture has to be scaled properly, and it has to have a method of doing that. Whenever you scale an image, there's multiple methods of scaling it, and like one of them is where you can like kind of blur the pixels, or you can like use like there's multiple different types, but basically in Minecraft you use you use the nearest here. So this basically means that it'll just take the nearest pixel and use that. It won't do any sort of blurring because we don't want any blurring in a pixelated texture game. So that's basically what that's doing. It's just setting it so it's pixelated pretty much. That's a very broad statement, but texture parameters are very complex. So I will get more into them if you would like, but for this, just getting a texture working, we're gonna go ahead and stick with this. So now we want to actually load the image because right now we just have an empty texture ID. So let's go ahead and load the image. And for this, we're going to first set a parameter for our STB image, which is the library we just imported. And this is because STB image uses inverted coordinates. It goes from top to bottom and not bottom to top like OpenGL does. So for this, we're going to do STB image.stbi set flip vertically on load 1. And this just means true. 0 would mean false, 1 would mean true. We do want it to flip just so we don't have to adjust our texture coordinates whenever we create them. Now we need to actually create the texture itself. So for this, we are going to we're going to do image result, and then I'm going to say this is the dirt texture equals image result dot from stream. And for this, we're going to do this long argument here. Okay, so for this, we need the file dot open read, and then this takes in the file path. And so for this, what I do is I do the file path here for textures. So for me, this is // textures, and then slash, and then I'm going to actually, because we're only loading just this, I'm going to just do slash, and then the name of the texture is dirttext.png. So I'm going to do dirttext.png. Yes, it is case sensitive. And that should be loading it in. This is basically meaning go back 3 folders and then go into textures and then take this from textures. Then the second argument is how we're going to be like loading this image. And so we just want color components dot red, green, blue, alpha. There's a ton of settings for this, but we're just basically, we're loading this in as it is. So we just want red, green, blue, alpha. Okay, now we need to give OpenGL the texture data here. So we're going to do gl.textImage 2D. And then for this, we're going to target our currently bound texture, which is the texture that we are working with, texture 2D here. And then we need a billion arguments here. So we need the level, which is 0, the pixel internal format, which is also RGBA. It's just shortened for this one for whatever reason. And then we need the width and the height. For this, we're going to do dirtTexture.width, dirtTexture.height. And then we need the border. We don't want a border. The pixel format, which is RGBA again, pixel format.rgba. Then we need the type of pixels. So for this, we're going to do pixel type.unsigned byte, and then we need the actual data to send OpenGL. So we're doing texture dirt texture dot data. That is a very long line of code, but we are done with this, and for the most part you will just be using the same line of code for everything, so that's pretty cool. And now finally, let's go ahead and unbind the texture. So unbind the texture. So for this, we're just going to do gl.bind texture, and then we're going to take the texture target.texture 2D, and then we're going to unbind it. Cool, cool, cool. Now that it is unbound, we are done with this texture. So a couple more things. We actually have to use texture coordinates, and for this, we're going to have to create a new VBO for texture coordinates and the texture coordinates themselves. So here, let's go ahead and go here, and below the vertices, I'm going to create a new float array of texture coordinates. I'm going to call it text coords. And this is going to be 4 coordinates for each vertex, and they're going to be in the same order that the vertices are. So the top left vertex would simply, this goes from, I believe it goes from 0 to 1. Let me double check. I'm doubting myself. Yes, it goes from 0 to 1. Okay, so since we flipped it, 0, 0 would be the bottom left. So basically here, this would be 0, 0. This would be 1, 1 in our texture. And if we were to do, for example, 2, 2, we would see 4. We would see 4 of the texture. So that's what I mean by the wrap. Whenever it was wrapping, it would just repeat itself. Okay, so let's go ahead and create these coordinates. So the first one is the top left, and this is it only needs the X and Y. So because we're doing texture 2D, so 0F, 1F, and then we need the top right, which is 1F, 1F. And then we need the bottom right, which is 1F, 0F, and then we need the bottom left, which is 0F, 0F. All right, we have our text coords done. Let's go ahead and load them into this in a VBO here. So we're going to create some guidance here. So I'm going to do, this is the vertices VBO, and I'm going to create a little comment here, and I'm going to say this is the texture VBO. All right, And for this, I'm just going to create a new VBO here, and I'm going to call it int texture VBO. And for here, I'm going to do texture VBO equals gl dot gen buffer. So we're just creating it. It's the same process as before. So gl dot bind buffer buffer target dot array buffer, and then we need the texture VBO here. Okay, and now let's go ahead and put the data on it. So gl dot buffer data, and we need buffer target dot array buffer, and then we need the data itself, which is the texture coordinates dot length, multiply it by the size of a float because we want the size in memory. Then we need the data itself, so texture coordinates, and then the buffer usage hint dot static draw because it's the same as our other vertex VBO. All right, so now we have this. We need to actually give this data to our VAO to send it to the GPU. So for this, we're going to add a new slot on the VAO. So this one's pointing to slot 0. We're just literally going to copy this and paste it. And then we want this to be slot 1 instead of slot 0. So remember, the first argument in gl.vertex attrib pointer is slot 1. And this is still a float, so that's all good. But now it's only 2 instead of 3, because remember, we're only sending it in X and a Y position. And so now we want to make sure that we're enabling slot 1 as well here, and that should be all good. So now we have to go into our shaders and specify some stuff. So let's go ahead and go into our default.vert, and we need to add a new location here. So I'm going to do layout location equals 1 in vec2 a text coord. This is the texture coordinates. All right, and then basically what we do is we need to send this out. So we need to send it, but we can't just send it. We can't send this in as an out. We have to actually do this in our main method here. So we're going to do this. We're going to do text coord equals a text coord. I'm honestly not sure why you have to do this, even if they're not doing anything, but you have to, I believe, to my knowledge. So go ahead and do that, and then do out vec2 text coord. So this is just taking in this input that you get from your first layout for your layout at slot 1 in your VAO, taking it and then sending it out to your fragment shader. So now in our fragment shader, we need to do something with it. So we need to take it in first. Let's do in vec2, and then this doesn't need to be the same name as the one we sent out. So in vec2 text coord. And now instead of this vec4 flat color, we are going to do a texture, and this is going to take in the texture that we want, which is the texture 0 and the text coord. And then one more thing, we need to create a uniform, and I'll get into uniforms in a bit, but we need to create a uniform sampler 2D texture 0. And this is basically, remember that we made the active texture the texture 0. So we want to basically use texture 0 because that's where our texture is. And I know I was brushing over a lot of stuff there. I'm really sorry about that. It's a lot to basically put into one tutorial, but as we go along, I'm going to be explaining more of the details, more in depth. So bear with me. I don't want this tutorial to be 3 hours long. So let's go ahead and build the solution, make sure nothing blew up. All right, and now all we got to do is we have to bind the texture before we draw. So let's go ahead and do that. So for this, I'm going to bind it. I think I bind it. I'm going to bind it after the shader program. So gl.bind texture, and then we need our dirt texture. Oh, we don't need our dirt texture. We need our texture target texture 2D to specify which type of texture we're binding, and then we need our ID, which is our texture ID, which we created as a instance variable. So that's good. All right. And now finally, we're just going to do gl.delete texture, and then we just need the texture ID. Cool, cool, cool. That should be all good. Please don't break, and let's go ahead and run this. That is better than nothing. That is definitely better than nothing. All right, I figured it out. So complete mistake on my part. The spot where we are unbinding our VBOs and all this is not correct. So basically, whenever we add these attributes, we need the VBO to be currently bound in order to know what data to be putting onto the VAO in that slot. And I don't know why I wasn't even thinking about this, but let's go ahead and move where we are creating or binding these VBOs and putting the data on them so that we are like alternating this. So for this, what I'm going to do is I'm going to take this VAO here. I'm going to first bind the VAO. I'm just going to bind it right below where I created it. And then I'm going to, below where we created our vertex VBO, we are going to put the vertex VBO in slot 0 of our VAO. And so for this, we are going to take this and take it from here, put it right here. And then now for our texture VBO, we are doing the same thing where we are putting the texture VBO into slot 1 of our VAO. So the problem was that we were unbinding both of them right after creating them, and then there was nothing bound when, or the wrong thing was bound whenever we tried to put it onto our VAO. So now, instead we're going to unbind the VAO after we enable the attribute of our VAO for both of these. So let's run through the steps of this. So we generate our VAO first, we bind it to the current OpenGL context, then we create our vertex VBO, we bind it, we put the data onto it, and then we put this data onto slot 0 of our VAO, and then we enable that slot, and then we unbind the VBO afterwards. Then for the texture VBO, it's the exact same process. My problem was I was just unbinding the VBO too early, and I apologize for that. I should have planned ahead a little bit better, sorry. So now we get our square. There you go. Okay, so I apologize for the confusion there. But yeah, the code is on GitHub with the proper steps. And anyways, this whole wall of code here is going to be very soon simplified by our future tutorials. So with that being said, thank you very much for watching. Have a good day. See ya.